So hello everyone, welcome to our Intro to Swift workshop. We are very excited today, and just a couple of reminders of our Zoom code of conduct. So please do not annotate on the presenter's slides, as this is extremely disrespectful, and you will be kicked out of the Zoom if you were to do so. 2, please remain muted at all times unless you're called upon to ask a question. 3, please do not interrupt our speaker. And if you have any questions in the chat, please leave it in, if you have any questions at all, please leave it in the chat. And please do not ask our presenter to repeat large chunks of what he's presenting. If you have any questions, if you felt that you've missed some information, you could always refer back to our recording, which will be uploaded on our YouTube. And without further ado, I'm passing it on to our speaker.
Can you guys hear me?
Yep, we can hear you.
Great. Okay. So first of all, hello everybody. Thanks for joining in. My name is Eduardo. Let me try to figure out how to share my my slide deck here. How do I do that, Angela? I think I can share while you're still participating.
You should be able to now. Sorry about that.
No worries. Okay. Just a second. We'll have to let Zoom see my desktop. I guess I'll have to restart Zoom. Just a second. Can you guys see my screen?
Yep, we could see your screen.
Okay. So there we go. Awesome. Hey guys, so let's get started. Sorry for the technical issues here. I'll be leading your Intro to Swift workshop today. So let's go a little bit over the agenda for the workshop today. I'll start with some introductions, talk a bit about myself, a little bit about Shopify, the company I work for. I'm gonna go over some of the technologies, tools, and frameworks that we're gonna be using today. Some of them, alongside Swift, we're going to be building an iOS app with Swift. So we're going to be going over a little bit of about Swift, a little bit about internet protocols. We're going to be consuming an API from a free API from the MuleDB. So we'll go a little bit into some of the internet protocols we're going to be using. We're going to be building our app using Swift UI, which is the new declarative, newish declarative UI framework from Apple. So a little bit about, we'll talk a little bit about Swift UI, a little bit about Combine, which is going to be used alongside Swift UI for building our app's UI. We'll be talking a little bit about the new concurrency framework from Apple, a little bit about Swift Package Manager.
What was that?
And okay, and a little bit about Swift Package Manager, which is the dependency management system we're going to be using for adding a dependency to our project. And after that, we're going to be live coding for the rest of the workshop. So I'll try to show some of the expected results, explain why we're going to try to be live building something, and then, well, live coding always has its own pitfalls. So if you haven't participated in a live coding exercise before, I'll tell you guys, we might bump into some technical difficulties, but we'll be fine in the end. And then we'll be closing. I'll try to set some time later for some questions. And yeah, like Angela mentioned before, I'll try to be as interactive as possible. We do have a little bit of an extensive exercise. If we do have like lots of questions, I'll try to be as interactive as possible to not have a boring exercise, but we'll get over that. So starting with the introductions. So my name is Eduardo. The long name you guys might have guessed. I'm from another country. I was born in Brazil. I'm a mobile developer at Shopify. So yeah, I'm from São Paulo, Brazil. I went to the University of São Paulo. I currently work at Shopify. I work a lot with React Native, but I first started in 2012 as a programmer doing lots of Java SE. Later, I pivoted into mobile in 2013. In Brazil, I worked for 5 years at Token Lab. It was a software house where I started with mobile development. So I started with Android development, and then early on, I started focusing on iOS. I worked there for 5 years. I was kind of looking for, well, in software houses, you mostly build 1.0s for other companies. So I was on a quest to work for a company where I would be able to have a product to call mine. So in 2018, I left Token Lab. I went to work for Nubank, a fintech in Brazil. In 2019, I had my first chance to lead a team, an iOS team at Amaro, which, by the way, just became the first carbon negative consumer product company in Brazil. That is pretty cool. At Amaro, I also had the opportunity to lead the whole mobile team during the first year of the pandemic. And in 2021, I joined Shopify as a mobile developer. And as my ultimate challenge to impact the whole world with some of my stuff. I'm a big DIY person. I love building stuff. So my computers, my keyboards, they're all built by myself. I'm also starting with 3D printing. And I have been sim racing for the last couple of years now. So these are some of my interests as a person. So yeah, Shopify, the company I work for, is the leading global commerce company providing trusted tools to start, grow, market, and manage any size of retail businesses. Shopify makes commerce better for everyone with a platform that with not only the platform but also services that are engineered for reliability, while delivering the better shopping experience for consumers everywhere. Shopify powers over 1.7 million businesses all around the world in more than 175 countries, and is trusted by big players such as Allbirds, Gymshark, Heinz, Staples Canada, and many more. There are also the small businesses that we are proud to be supportive. So yeah. Shopify's mission.
Oh, sorry to interrupt, but I noticed the annotating. Unfortunately, I can't remove it, but you can. So
how do I do that? Well, I think I'll have to stop presenting, I guess. There we go.
So sorry about that again.
And now I annotated. So clear all drawings and then mouse, and then play. Okay. Want to close this one. You guys see the screen okay?
Yep, it looks good.
Okay. Okay, so Shopify is one of the greatest engines for economic independence on the planet, and our mission has never been more important to the world than it is right now. We are relentlessly aligned on one idea and outcome that unites us all. So we want a world where more people have access to economic independence, and a world with more economic independence is a better word for everyone. So at Shopify, our mission is always to make commerce better for everyone, our merchants, our consumers, and our mission is to make a world better for everyone. Okay, so like I mentioned, I'll go over some of the technologies. So yeah, Swift, probably why you guys are here today to hear about. So Swift is a powerful, concise, yet expressive programming language designed by Chris Latner's team at Apple. It was first released in 2014. It was designed to replace the not very modern anymore Objective-C language as the official language to develop software for Apple platforms. So not only iOS, not only Mac OS, but now we do have iPad OS, we do have Watch OS, TV OS. So Swift is the official language for developing for all these platforms. Apple wanted to create something as fast, performing, and extensible as Objective-C, but safer. And I should highlight safer here because you guys will see when we're building some stuff with it that it won't let us do things the old unsafe way as Objective-C kind of encouraged us back in the day. So yeah, Swift is as easygoing as some other script languages as JavaScript, Python, but it's very structured without being so stiff. That's why I like it so much. In 2015, Swift was made open source under the Apache license 2.0. And in 2019, it reached source and binary stability with Swift 5. This means that operational systems now ship with Swift runtimes, resulting in simpler, less rushed development in the part for us developers. And it will result in also into smaller, quicker launching apps for users. So this is a big step for us Swift programmers now. Some of the features that I also would like to highlight here for Swift. Objective-C didn't have generic types, so Swift has a lightweight, really easy to use generic type support. So it also leverages lots of protocol extensions and protocol-oriented programming for generic code writing. Swift is also closures and functions are also first-class citizens in Swift, and we do have actual support and access to some of those functional programming patterns. So we can use maps, we can use filters, reduces, all these nice high order functions. Swift also has a second and none pattern matching for in really powerful enumeration types. We will also see some of that while we're live building the app. And Swift does have support for reference versus value types. So back in Objective-C, everything was a reference type. So if we would have a class, that class was a reference to a space in memory. So if different parts of our program had access to the same reference, they would both be able to change the same space in memory. and that is not very thread safe. Nowadays, we're always have we're having more and more capable devices with more and more cores. So if we do have something that is not very safe in terms of concurrency and race conditions, that is going to be affecting our ability to write quality code. So Swift has introduced the concept of value types, which is one of the nice things we'll be looking into. And Swift UI is very clever into leveraging this into building very, very snappy, very performant UI. So value types are not like references. So when you declare a value type, it will have its own space and memory. If you try to get a reference to that, you won't be able to do that. So the compiler will be able to copy that reference type, that value type. So we can introduce a concept which is called immutability into our code, which will help us write very a code with more quality, more easier to deal with some of those concurrency pitfalls. So yeah, like I mentioned, we will be consuming the MioDB API. So I'll be going over some of the internet protocols we're going to be using. So this is these questions are a bit hard to answer. So I'll try to be very brief on what is the internet. The internet is nothing but a computer network that connects computers all around the world and makes communication between them possible. Without the internet, we wouldn't be able to consume an API, for instance, and we wouldn't be able to create the app we're going to build today. This communication is only made possible because of protocols. What a protocol is, a protocol or protocols in general are sets of rules that dictate how communication works. So human languages, for instance, like English, French, Portuguese, Spanish, they're all sets of protocols. I'm now speaking in English and you guys are probably understanding me or not, even though I'm from Brazil and my mother language is Portuguese. So we are born to different languages in different countries, although we still understand each other because of communication protocols. So computer networks are designed in a layer model. So each layer has its own protocols, its own ways to communicate itself. So the basest layer of computer networks is the so-called physical layer. It's where like electricity is transmitted, or in a cable, or in the case of like mobile mobile devices, radio waves are transmitted through the air. And we scale up into those layers as we communicate from computer to computer. And we are going to be working mostly on the topmost layer of our networks here. So we're going to be working in the application layer. That's where most of the visible internet exists. So in this workshop, we're going to be interacting with mostly two of these protocols in the application layer. The first one being the HTTP protocol. HTTP stands for Hypertext Transfer Protocol. It's how mostly of the websites and like the visible internet works, how we communicate between web servers and our browsers, our apps. And we're going to also be using the REST architecture. REST architecture is, REST stands for Representational State Transfer, and is also a set of rules and communication protocols that are going to be helping us communicate between our app and the web server that is providing us with all the information we're going to be consuming. Yeah, so that brings us to Swift UI. Swift UI is, like I mentioned, it's a framework for building not only iOS apps, but up until iOS 12 and roughly 2018, user interfaces for the Apple platform were built by developers in an imperative paradigm. The code that we would write to build UIs. So UI stands for user interfaces. So I'll be using the short for that now. The code that we would write to build UIs up until iOS 12 was what dictated, the code dictated what to draw. So how to draw shapes, where to position controls, what size something should be, what color something should be, what would be the animations from one state to the other state. So this is what we call an imperative paradigm. We would tell the computer what to do. In 2019, alongside with, well, I said 2018 before. So in 2019, alongside with iOS 13, Apple released SwiftUI. SwiftUI is a declarative and composable UI framework where the code is the UI itself. So instead of you writing code that tells the computer how to build the things you're going to be seeing, the code is the structure of the things you're going to be seeing. So this declarative approach has been addressed by, if not all, the majority of the major mobile players. So React Native has it, not only for React Native, but also for React on the front end. Flutter has also a declarative approach to its UI. iOS is SwiftUI now, and Android is also addressing that with Jetpack Compose. So SwiftUI was created with building apps across all Apple's platforms in mind, and including multi-platform apps in the sense where, in this case, in this specific slide, we do have the same app that is running both on iOS and macOS. So SwiftUI will help us with that, and we will see a little bit of its power while we're building our app here. Apple also focused a lot on performance, so it will leverage some of that value versus reference type features that I mentioned before to increase performance over vanilla UIKit. So UIKit was the imperative paradigm we used to use before. And we also do have lots of improvements in accessibility, interactions. So voiceovers are better with SwiftUI. We do have UI that is more efficient for wearable apps. So if we have an app that runs on a Apple Watch, for instance, SwiftUI will also help us save some battery, and that sort of thing is very valuable when we have a device that has a very constrained set of hardware tools behind. Yeah, so Apple also released Combine alongside Swift. So Combine is a functional reactive framework that will enable us to handle asynchronous events over time. SwiftUI leverages Combine to help us make the UI responsive and make reactive changes to the app state. We will also be looking a little bit in depth into it, but we will not be going very deep into specific Combine here. We will be leveraging Combine to make our app more responsive, but not into lots of Combine itself. Yeah, so that's how we'll be using both of these features together. But yeah, I have been talking a lot now, a little bit over 15 minutes now. So yeah, let us start some of the live coding I promised you guys. We should expect, well, this is a bit of what we should expect of the app that we're going to be building today. It's a it's a meal kind of catalog thing. So we will have a list of meal categories going from like beef, chicken, seafood. We'll have under each of these categories, we'll have a list of meals that correspond to that category, and we'll have a detail page for each of these meals. Some of these do have details. Some of these will show ingredients lists, instructions. Some of these won't, and we'll be looking into addressing all of these differences and building it into a very responsive app. Right now, the code for this app is already available for you guys if you want to check it out on the QR code on the bottom of the screen. If you guys scan that, that's the Git repository for this app. So this is available right now if you guys want to take a look at it, or later if you guys want to study it a little bit. But yeah, this is what we will be trying to build today, and hopefully succeeding, right? Yeah, so why are we live coding this? Well, because live coding is pretty cool in the sense that we can see things being built in a way that we can understand how they work. But also Swift UI is very composable, so we'll be able to create very progressive steps in a way that we'll be able to create a simple list. We'll be able to be styling it the way we want, and it's very progressive because Swift UI will let us be very composable about our application. And yeah, I'll be switching over here now from the slide deck to Xcode. I'll be using Xcode 13 and iOS 15, since some of these features I'll be going over are pretty bleeding edge. So if you guys want to accompany me here, make sure you guys have both, I wouldn't say the latest, but at least macOS Big Sur and Xcode 13. Well, it's still in beta. I think I have beta 1 here, but beta 1 to 5 should also work. So yeah, I'll be going over to Xcode now, and we'll switch it over a little bit. Let me also change the screen. I have two monitors set up here. And can you guys see the other screen now?
Yep, we can see your screen.
Great, awesome. So we'll be creating a new project from scratch now. So file, new project. Let me grab the new screen here. Okay, so we do have the option here to select the different platforms we want to be writing our app for. So tvOS, watchOS, macOS, the multi-platform thing that I mentioned. We'll be focusing on iOS right now. The simulator is a lot lighter. It will help us have a more performant experience here. So we'll be creating an iOS app. Well, the product name will be the MealDB. And I will be showing you guys what the MealDB is. We will be using Swift UI for our interface. So Storyboard was the previous technology we would use if not for Swift UI. And we will be using Swift as our language here. So we just hit next there. Let's create another folder here. So the MealDB, it's already taken. workshop, create a new folder, and create a project inside there. There we go. So this is the first screen we'll be looking at. So when we create the project, Xcode will also create some of the scaffolding that we'll be start working on. So it gives us a hello world here. And one of the nicest features Swift UI will give us is the automatic preview. So in every struct view that we're building, we can have a preview for that. So in this case, let's resume that. And I don't have the simulator running yet, but Xcode will be previewing our interface on this side of the screen here. So let's give it some time to think. And hopefully it will be quick enough. While we're waiting, let's take a look at the MioDB. So the MioDB is a API. It's a free API that we'll be using today. We can, if you guys want to support them, they do have a Patreon support format thing. But we'll be using the API like it's showing us here. So the first API that we will be consuming is the category API. So we'll list all Mio categories. And if we take a look here and open this up on the browser, it will return all of the categories from that they know there into a JSON file format. This is a little bit hard to see. So let me bring my trusted file editor here. We'll paste that and we'll validate and format the JSON for a more visible thing. So it will return us an array of categories. Awesome, a list of all the categories that they know. So every category will have like an ID. It will have a category name. It will have a category thumbnail. So it's a picture that will show like the category picture. And it will also have a description for each of them. Yeah, for our first screen, where we will list all the categories, this is the API that we will be consuming. You can see we have like lots of categories here, so this will be pretty fun. Let's say if Xcode already, okay, it already showed us our hello world here. So like I mentioned, we do have in Swift two different types. So types of structures. So we do have structs. Structs are what we call the value type. So every time we create a structure, a struct, it will be created in memory in a separated place from other instances of the same type. So this is one of the ways Swift UI will have our UI be performant. So it leverages the structs. Before, we would have like something called a view controller, a UI view controller. And a UI view controller was the object that used to manage the view hierarchy for your UI kit app. UI view controller was a class, and a class is a reference type. So if we create a class here, let's say Vio, this is a class that is a reference type. If we create a different, if for some reason we create a meal, so let's instantiate a meal, let meal equals meal. So we are constructing a meal object into our meal variable here. It's not actually a variable. Swift does have two different variable types, let's say. So we do have vars, which are actually variables where we can change the value that is inside. And we have a let, which is a constant. So we first construct our variable here, our class instance here, and we will not be able to change the value over time. In this case, okay, that was just a stale warning there. So if we do have, for instance, meal2 equals meal1, meal without a number, what this will make is this will create a space in memory for meal, where it has a meal instantiated there. And when we do this, well, it is actually complaining because we cannot initialize a variable with another variable that is being initialized at the same time. This is one of the safety features that I mentioned before about Swift. If we would try to do that in Objective-C, that would probably let us do that. Swift does not. So we cannot use an instance within its own property initializer. So it's complaining because we're trying to use meal before meal actually finished initializing itself. Some of that thread safety, concurrency safety features there. But what this would happen if we would be able to do that, let's put that inside our body here so it won't complain. This would create meal inside a place in our memory. And when we try to say, let's say meal2 equals meal1, what we are going to do is create another reference for that same memory space. And we would have, if we change meal2, we are changing meal1 at the same time. If we change this to a struct, what we're doing is creating, we're saying that meal now is not a reference type anymore, it will be a value type. And if we do this, let meal equals meal, and then let meal2 equals meal1, what means is that we're creating a new memory allocation space for meal2 that is a copy of meal1. So if we change meal2, we're not going to change meal1. And this is one of those features that I mentioned before. This is immutability for value types, which will be very, very important for SwiftUI to leverage and create the UI for us. So let's go back to this. So yeah, SwiftUI, Xcode created us this very interesting format here. So what we see here, Swift created for us, Xcode created for us the MealDB app, which is the starting point for our application. So by saying main here, annotating this structure, the MealDB app as main, we're saying that our app will start from this class here. And every time we run our app, it will be created via this structure. In this case, well, SwiftUI has this structure where when you have apps have scenes, and scenes have views inside of them. So we do have apps. Inside an app, we have scenes. Inside scenes, we have views. In this case, our app is the MealDB app. Inside our MealDB app, we have a scene, and inside of this scene, we have a content view, which is this structure that is created in this other file here. And inside of the scene, we'll have a view. Okay. This sum keyword here is something that is very important and was probably created for SwiftUI. This is what's called a opaque type. So we're saying that inside the body of our app, we'll have some kind of scene. We don't actually care what type of scene that is. We just want that inside that we'll have a scene. So window group is a kind of scene, but we could have other types of scenes inside. We'll not go over that, but for iPad OS apps, we can have multiple scenes being shown at the same time inside an app, not on iOS though. So we'll be using window group that will this actually says, okay, we'll put content view inside the window of our application, and our app will have a window group scene that will have a content view inside. But this is how we are putting things inside our app. So the content view was also created by Xcode when we created the project, and it also has a body. So the content view will have a body, but in this case, it's not some scene, it will be some view. The same way, we don't actually care what type of view is inside our content view. We can have, for instance, in this case, we have like a text label saying hello world with a padding around it. So you can see here, there's a little bit of padding around the hello world string. So the content view actually doesn't care what kind of view is inside. We'll just have to provide some kind of view. And the same thing for previews here. So our content view previews are going to be some kind of view that it doesn't actually care. In this case, it's previewing our content view. So if we change here, let's say hello world, instead of saying hello world, let's say hello SuperPOSITRON. It will still be a view. And the content preview here will update that to hello SuperPOSITRON on our preview. So this is pretty cool. We haven't had access to something like this before, Swift UI. And we'll be using mostly the simulator, because our app is pretty lightweight, in a way that launching it on the simulator is not very slow, but we would be able to just preview everything on our preview side panel here. So what I will be doing is we'll be running our app on an iPhone 12 simulator, so we can see that we have the same thing. The simulator will be booted up. There we go. And we're launching our app, and we'll see the same thing. But now this is an actual device simulator. So we can see this is an iPhone 12 running iOS 15. Let's give it some time to start up. While I would do that, I would be going to close the preview panel, because that is a little bit heavier than having the simulator itself running. And there we go. So the simulator shows our hello SuperPOSITRON text label. Awesome. But we do want to show all our nice meal categories, right? So we'll be creating a list. The first Swift UI component we'll be going to use is, instead of text, we'll be going to be using list. A list is the structure that will help us show multiple components in the screen. So a list is a container that presents rows of data arranged in a single column, which is exactly what we want. If we just create a list, we can also put a text inside, because a list as the container view also is a sum view. So it will require us to provide it with other view components inside it. So let's say hello SuperPOSITRON again. And then let's actually do that a couple times, and let's run the app again, and let's see what happens. There we go. Now we have a list of hello SuperPOSITRONs, and it also scrolls. If we would have like more of these, we would be able to scroll it up and down. But for now, that's all we're going to be needing for our meal category list. So okay, this is great. But all these categories, they are provided to us by the MealDB server. So we'll have to contact them for that. So we'll be creating some code here. We'll be writing some code here to make the the network calls that will, the same way we, on Google Chrome, we just pasted the URL here, and it gave us the list. We'll do the same thing, but on our app. And for that, we'll be using what is called a URL session, which is the way iOS wraps around HTTP and the HTTP protocol. So we'll be creating a new file here. So let's start up with some of the organization part of our project. We'll create a new group with it, which is just a folder inside our project structure. And we'll call this a model. Our model folder will hold our new file that we're going to be creating here, which is a meal categories model. One of the things that I previously mentioned is that Swift UI helps us be very modularized and very componentized in our way to write code. So we'll be creating separate classes, separate structures to do separate things on our application. So we'll leverage a concept of software engineering that is called forgot the word for that in English. It's separation of well, we have different responsibilities for different classes. We'll separate the responsibilities in different places. I'll get back to you guys when I remember the word for that in English. So what we'll be creating here is a class in this case, because we do need this to be a class, because normally structs are very good for creating immutability and creating things that will be very performant for Swift UI. But in this case, we want this to be a specific place in memory. So we'll have a class that is called the meal categories model. And our meal categories model is what will have, for instance, we'll declare a function called fetch categories. And our fetch categories will go to our MealDB server and will retrieve that data for us. So the first thing, like I mentioned, we'll be using a session, an URL session. There we go, an URL session. We'll be going to be using a specific one, which is the shared URL session. This is shared throughout the whole app, so we can use the same session for all the HTTP requests we're going to be making to the MealDB. And we can do something like this. So we'll be saying session and give me the data for, we'll be using this specific call of session. So this is an URL request, but we can use the specific URL here. So we'll be creating a URL from a string, and we'll be grabbing the URL that they provided us. So we put that URL here. This question, this exclamation mark here means that we are creating. So when we try to construct an URL from a string, you can see some of these. Well, let's try again. URL from a string. You'll know that it will return an URL with a question mark. This question mark means this is an optional variable. This is an optional value. So what means here is that if it isn't able to create an URL from a string, it will return a null URL. So this is some of those safety features that we have in Swift. If we do have something that is specifically marked as optional, this value might be not here. The value might be here or not. So we have to defend against this kind of thing. In this case, I'm not very fond of doing this. But we do know that this is a well-formed URL, so we can just say, okay, take that optional URL and give me the value inside. If it is null, it will break the app here, but we are pretty certain that it will not happen since we are giving it our own value here. So we're pretty sure that this will be a well-formed URL. And let me remove this. We're not going to be using the delegate here. So the first thing here is that if we take a look at the session.data function here that we're going to be invoking, it's saying, okay, it's an async function. That means if we're going to be doing a call to a server, it's not going to be happening at the same time. So our app will call the server will do some processing and will return us with the list of categories. And this is an asynchronous process. It is an asynchronous process, so it will take some time. So what we have to do here is run this asynchronously. This is a pretty new feature from Swift. This is why we're using Xcode beta in iOS 15. This is the new concurrency framework that iOS 15 just brought up with, that Apple just brought up with iOS 15. So this is something pretty new. And I'm very excited about this because this will help us write asynchronous code in a very simple, very organized way. So what it's saying is that data is an async function and should be used in a context that supports concurrency. And right now, this context does not support concurrency. And what we need to do is say our fetch function is also async. So we can call an async function inside it. Ambiguous use, well, so what happens when we call the data function here on session is that we want to grab the data that it will download. So it will give us a tuple. A tuple is also a nice, very good feature that Swift brings to us, which is we don't have to create a specific structure or a specific class to hold something. We can just say, I'll have like two values that are inside one group of values. So we'll have data and we'll have response. Response is the class, is the variable that will be holding some of the information that our session data download will be returning. And data will be the actual data for this JSON here. Obviously, in this case, data will be a data object, and a data object is the representation of this JSON in binary. So we'll have to after downloading the data, we'll have to convert that back into a JSON, and then the JSON back into something that we can work inside our app. So let me take a look here and try and understand what is happening here with our session. Let's just, Xcode has never had a really good, it always gives us like very stale warnings. It will take a second to remove the warnings there. So let's say, let's declare this tuple, let's say data, and well, for now, we'll ignore the response part of the response. So we can say, ignore that with this underscore here. And we'll be saying session data from, oh, okay, I was using the incorrect function. So we have data for URL request, and we have a data from an URL. So we're using this function here instead. So it's an URL from a string. And then we have that string, which is this one. Awesome. And then we can just say, okay, give me the string, and give me the URL. I assure you that this is safe. Okay, so we do have another problem here. Remember when I said data is an async function? First thing we have to do when we call async functions is saying, okay, let's await for this because this is asynchronous. So when our code gets to this line, let's say that we are going to be awaiting for the response of this data function. Another thing that happens here is that data can throw an error. So if we try to download something or get some data from a web server, and maybe we skip the ladder here or something like that, we can get an error. What the compiler here is giving to us is that this call can throw, but we are not can throw an error, but we are not handling this error that can be thrown. So the first thing we do here is using the keyword try. Let's say also that our fetch function here will throw the error. So if we're trying to await for the session to return data for us, and it returns an error, let's say that our fetch function will also throw that. So we'll say we'll rethrow the error and let other parts of our program to worry about that. And this is still a little bit a problem here because, okay, so what I said, this async await feature is new to iOS 15. So let's do some tweaking here, and we'll save the development info here for our application. So we have our mealdb here, our specific target here. We do have it saying that it will be built for iOS 14 and for iPhones and iPads. We can, for instance, unmark iPad here, and we'll not be able to run this app on an iPad, but well, it's not a problem right now. So we'll be selecting iOS 15 here, and we're going to say, okay, this app will only run on devices with iOS 15 or newer. So we go back here, and we'll probably get rid of that error. Awesome. So, okay, nice. Immutable value data was never used. Great. This is good because now it's not an error. This is just a warning here. And it's saying that if we're not going to be using that, consider changing that with an underscore like we did with the second part of the response here. For now, we'll go ahead. So we do have the structure of our categories here. So we know that when we're calling this API, we'll receive an array of categories and a list of categories. And we want to be able to get all the strings and IDs and thumbnails, that kind of stuff from the categories. But like I mentioned, when we use this data function, it will return for us a data object, which is a binary representation of this text. So what we want to do is we'll be creating what we're going to be calling entities. An entity will be our representation of real world things inside our app. So we'll be creating a file here that will be called neo category. So we'll have a list of neo categories, right? And let's create a structure. So we want this to be immutable because we'll be creating them, and we don't want the app to be able to change that during the runtime. So it will be a struct. You will remember that we have like these different kind of these different fields on the JSON. So we will create a neo category struct, and we'll be creating fields for that. I don't really like the name that the API has given to the field, so we'll just go, for instance, with we'll have inside our struct, we'll have a category ID, or well, this is already a category, so we'll have an ID property inside our structure, and it is a string, so we'll say it's a ID string. We also have a string, a category name, right? So we'll be calling it name instead of str category. We also have a thumbnail. So we don't want to call it str category thumb either. So let's call it thumbnail. Also string. We don't have, we won't use the description for now. So we're okay. But doing this change of names here, we'll have to do some work into like translating the JSON into our structure, neo category here. But what I want to show you guys is the codable protocol. The codable protocol is a way that we're going to say this structure can be encoded and decoded from and to binary data format. So we're going to say our neo category is a codable structure now. And what a codable structure does is if all the properties inside it are also codable, we have that translation from data to strings, or from data to a JSON. It is done for us by the compiler, which is pretty awesome. We don't have to write code to transform this JSON list into our list of categories. So nice, it is codable, but how do we know that like ID category will be translated into our ID property here? We have to create something called a coding key, coding keys. We'll create an enumeration because we have an enumerated number of fields. Our coding keys will be of the type string because the names of the fields are strings itself, and it will also be implementing the coding key protocol. That is a type that we are going to say that is going to be used for encoding. It's going to be the keys for coding and decoding our structure here. So, okay, it declares, well, it's all errored out because we have lots of things that aren't really code here. But we'll say, okay, we have a case for this enumeration, and it is ID. So when what do we want to put inside ID? We want to say ID is ID category. So doing that, we're going to say, okay, if the JSON has an ID category field, decoded into our ID variable here. And we'll be doing the same thing for all the other fields here. So field name, which is called str category. And the same thing for thumbnail. Thumbnail is the str category thumb field from the JSON. We can just erase this, which is great. Now we say that we are going to be holding neo categories into IDs, the neo categories ID, name, and thumbnails inside our structure type. And we're telling the compiler how to do the translation between the JSON field names to our structured property names here. Another thing that I want to point out here is that we still have one step here. So we do have a list of categories. Each of these categories will be translated into our neo category structure here, but we do have in the root part of the JSON, we have a category list array here. And in this category list array here, we'll have to also model that into our entity. So let's create another structure here, which is called neo categories. I guess this kind of works. It's also codable because we also want the compiler to provide us the translation, the automatic one. And well, categories is pretty good for me. So let's just call it categories. In this case, we won't need to implement the coding keys for that. So this is great. And what categories is? The field categories is a list of category. So we are going to be having a list of neo categories here. And we're good with the compiler. So, okay, Remember what I said? So strings are codable. So we can say that Mio category is codable and we don't have to do anything else. And the same applies to Mio category. So Mio category is also codable. A list of Mio categories is also codable. So we can say that Mio categories is codable. And we're good with our translation from our JSON, the data, and all that to our models here, our entities. So in our model here, we do have a data object here, but like I mentioned, it's a data object. It's a binary representation. So let's say we're going to be creating categories. Categories is we're going to be using JSON decoder. So we know that our data comes in a JSON format. So we're going to be using a JSON decoder that decodes data from a JSON format into our categories. And we're going to use the decode function from the JSON decoder. And we're going to say, okay, let's decode. What type are we going to be decoding? We're going to be decoding Mio categories from that. So we say self here means that we're using the actual type itself, the actual Mio categories type, from the data we are grabbing from the session, the URL session. So we just do data here. It should be happy with us. Okay, yeah, the call control, because it can throw an error, because the thing that we're giving to the JSON decoder might not be decodable to this specific type, right? It can be a different JSON that does not translate into the Mio categories format we are expecting. So we will also have to try to do that. If we are not able to do that, in this case, our function also throws, so it will rethrow that error to someone else. We are not going to be handling that for now, but awesome. Initialization of immutable value categories was never used, but if we take a look here, we see that our categories variable here, in this case, it's a constant because we use the let word here. Categories is a Mio categories, which is great because we can take a look into categories, and categories will have a categories property like we defined before, which is a Mio category list, which is great. If we can do like, we get the first category there, and we'll have like the name, the ID, the thumbnail for that category, which is awesome. And we'll be going to be using that for our list. So awesome. We downloaded the data and we translated that into our category object. Now we have to put that inside our Mio category. Oh, I'm sorry, inside our content view, right? So we have a list here with lots of text that I created by hand, but I want this list to be dynamic. So first thing we will do now is start leveraging that combine functionality. So combine will help us tell like our content view will be receiving asynchronous reactive data from somewhere else. So if the feature we are going to be using in this case will be, first of all, we're going to say that our category model here, it is of a specific type. So we're going to say this is an observable object. Saying the Mio categories model is an observable object means that we're saying that our app, that our Mio categories model now is part of the Combines framework, and that we will have values inside our object that will be updating from time to time. So our Mio categories model is an observable object, and we can say that we have a published value here. So we'll create a variable that is called categories here. And categories is of the type Mio category, a list of Mio categories. We can say that it will, the first value before we load data from the server, it will be an empty list, but we'll be updating that once we get data from the server. This published annotation here, this keyword here, tells that, okay, we do have an observable object, and it will be updating data from time to time, and the data will be published on this specific variable here. And it's saying that this will be a variable that updates from time to time. And when it updates, we will want to have those updates in hand, so we can, in this case, put the meal category list into our list object on our list on the view here, our list thing here. So we'll be going back here and to our category model. And okay, we did get our categories, but what we want to do now is, okay, let's grab these categories and put it inside the categories object that the categories list that we created just now, the published one. So our published categories here will be equal to categories. In this case, this categories here is a neo categories, which is the one that has categories inside and then array inside. So there we go. Our published list of neo categories here is is the categories inside the categories that we got from the server. This is actually a very nice piece of code. Like a couple of years ago, if we wanted to grab some data from a server, it would take us more than like 3 lines of code in Swift. And this is to show us how Swift has come, how far Swift has come as an actual very good and modern programming language. But yeah, so what we're saying here, we download data, we try and wait for our session to return us the data from this URL. We try to decode that JSON and set inside our neo categories variable here, and then we get the array of neo categories, the list of neo categories that is inside this JSON, and we put it inside our publish value here. What this will happen every time we update something that is a published property inside an observable object, the observable object will, in its turn, tell the rest of the other parts of the code that are watching to any so this is an observable object. We will have also observer objects. So if we change the value of the published categories here, our observable objects will on its turn go and tell all the observer objects that its value has changed. So we'll be leveraging that to make our list update its value. So let me see. Okay, so we do have a list here. So we want to, like I said, we do have like an observable object. What we want to do here now, we declare an observed object. Observed. Let's satisfy this before. Let's return just a text without nothing inside. Good. Okay, so we want to create an instance. So our view needs to know our model so we can fetch data, right? So we'll have a variable here, and we'll hold our model, which is a neo categories model. Awesome. And we want that to be an observed value. Observed object. I'm sorry, observed object. So we're saying that here we're saying that this is an observable object, and here we say that we're observing it on our application. So, well, let's forget our previews for now. It's missing the model here, but we'll see to that. And what we do is okay, we now have a list that will look into our model, and our model has a list of categories. So we'll create a list of that, and for every category on the categories list on our model, we'll have one meal category. Meal category. And this is what is called a closure. Like I mentioned, this is a first-class citizen in Swift. So we're saying that for every meal category on our model list, run this function, this closure, this block of code. So we know that meal category here is one of the objects that are inside our meal categories list here. So getting back to it, let's just do like, I want a text for each category. I want a text that has the meal category dot name inside. So we have a list of all the meal categories, the meal category names. Oh, okay. So this is another nice reminder for us. We can do this, but we have, but to do this, we have that we need to have our category objects, our category structures. They need to be identifiable, so the list can know which is which. So if we're scrolling through them, it knows how to show them. So it's saying that it requires our meal category object to conform to the identifiable protocol. So we'll be going to our meal category here, and also not only codable, it will be an identifiable object. Identifiable will have us implement one of its requirements is that we have inside this structure, it requires us to have a variable called ID that will identify our identifiable object. So I'm sorry, there you go. Doing that, so we do have an ID, and at the same time we're saying that the ID will be the ID category from the JSON. So it's both identifiable and codable, and we have the translation from ID category to ID. So we should be good here. And if we go back to our content view here, it should be satisfied by that. Great. We still have an error here because now we're saying that our content view needs to have a model, and in our app here, it's missing. So it wants us to tell what's the model that we're putting inside our content view. So we'll just be doing a meal categories model, a new one, and that's it. We should be able to just run this. And now it won't do anything by itself, but if we go into the content view and we use the on appear function on the list, so when the list appears, on appear will be saying, okay, fetch the categories for me. It will complain here because this call throws an error, and it also is asynchronous. So let's first go for the async part. So we can say that this is asynchronous and put it inside an async block. First part is good. The second part is that it throws an error. Let's change things around a little bit. So we go back to our model here. Let's say we don't throw it anymore. We'll just handle the error ourselves on the meal categories model. So we'll just do, okay, so I'll show you guys a pretty cool feature that Swift has, which is we do have if blocks in Swift. So when we want to check for something, we check if something happens. So if number 2 is bigger than number 1, we will execute things that are on the first block of code. if 2 is not bigger than 1, it will run this other else block of code, which is a pretty normal programming structure. Swift has what is called a guard block. A guard block is an inverse if. So we are guarding something that it should happen, and our code should not continue if our guard block is not satisfied. So we will be doing the same thing here. So we guard let data equals await session. But instead of doing a hard try here, we're going to do an optional try. So if our session data throws an error, we'll just have an optional block here. And what we're saying here, we guard that this is this optional tuple here is not null. So if it is, we do have an else at the end. So I'll write this. This will sound a little bit confusing, but and also the guard block will require us to finish our execution inside its block. But this code here means that we'll try to grab data from our session. If we can do that, we can just go ahead and do the other things we want to do. If we do get an error, it will go inside our guard block here, and we'll just return. So we just return from the function, and we don't do anything else. We'll do the same thing for categories here. So the decoding part can fail. So we will do the same thing. We'll do a guard let categories equals trying to decode the meal categories from data. If we're not able to do that, we just return from our function without doing anything. If both of these guard blocks are satisfied, we'll have the categories, and we'll grab the categories and put it inside our meal category variable here. And when we change that, it is a published variable, so it will tell its class that it has changed. Since the class is an observable object, it will tell all the observers to this observable object that this class has changed. So this is what will tell our list that our categories have changed. So we will await for our model to fetch our categories, and we should be good. Let's take a look. This is the part where live coding might not work, and I will be left seeing what's wrong, what happened that we didn't get the data. But we did get the data. So we did get the specific meal categories, which is pretty cool. And they are on a list, they're scrollable. If we had more of these, we would be able to scroll that and go ahead and see the whole list of things. One thing that we also know is that inside our meal category, we do have a thumbnail for that. So let's try to put that image there. Unfortunately, it is pretty easy to download data from our server, but it's not as easy to grab an image from the internet. So we'll be using a dependency to do that. And we're going to be using a specific dependency called Kingfisher. So we're looking for Kingfisher. Kingfisher is this pretty meaty library. That Kingfisher is a powerful pure Swift library for downloading and caching images, which is also great because we don't want to be downloading the same image over and over again and use all our users' internet, right? All the data plan he has on all the data plan the phone has. So we'll be using this this dependency. Kingfisher will handle the images for us. So we'll be using Swift Package Manager. So let's take a look here. Okay, installation, detailed guide for installation can be found. We'll add Kingfisher to our project as a dependency. In this case, we'll forget about selecting the specific version because this version here is wrong, but we'll go back to our project here and we'll be adding a dependency to our project. So we go to the MealDB and we go to our project and we have the Swift packages tab here. So we can add a new dependency to our project. So if we just put the URL to the GitHub here, and it will search. I already did that, so it's already on the recently used list here, but we'll be using up to next major version from version 6.0 instead of 7.0. Forgive me. And add that to the project. Let's add the package. Xcode will fetch the dependency. We'll check out. Yeah, choose the package product. This is the one, add package. And now we do have a dependency here. So we have Kingfisher 6.3.1 added to a project, and we can use Kingfisher to get some nice images. So let's go back to our content view here, and we want to have beside just if you guys remember from the slide deck, we want to show the thumbnail and then the category name. So what we do, we create, since we want to have them side by side, we create a horizontal stack. So they are stacked horizontally, and we are going to be importing Kingfisher into our file here, using KAF image, which is the the view that Kingfisher uses for fetching the image for us. It does have a parameter for giving it the URL. So we'll say, okay, the same way we do show the name here, we just go over there and neo category dot thumbnail, and we also put the text here. Oh, okay. It expects an URL, so an optional URL. This is great because they are already doing that thing that we did before. So we don't have to put the exclamation mark here. And we'll be showing oops, okay, we do have some images here. They are all weird and they're taking the whole screen, but we do have some images, which is great. So the thing is, we'll have to format a little bit. So we'll get, let's say we want this image to be, let's say 50 pixels by 50 pixels. So we do use this following configuration here. So we're saying that while the images are loading, we want to show a progress view, which is like the activity indicator, the spinning wheel. We're saying that this image is resizable. We want the content inside to be scaled to fit inside our 50 by 50 frame. If we run it again, it should show the right size now. Wow, this is pretty cool. So now we have the small thumbnail beside every dish here. We do have 25 minutes still, so let's do the navigation to the next page, which will show the dishes inside the specific the specific category we are showing. So to do that, we're going to be using the navigation structure that iOS gives to us. So if we click something, we'll navigate to the next page. To do that, we have to wrap our view with a navigation view. And just by that, like I mentioned, Swift UI is very composable. We just grab everything we had and put inside the navigation view. And we're going to say that, okay, on appear that happens. And if this list is shown inside the navigation view, we want it to have a title. So we want to add the navigation title property to the list. So we're going to say we want to show Neo categories every time our list appears. So if we run the app again, we should see the list, the header name here. So which is also pretty cool is that iOS also gives us like this pretty neat animation here. So we do have a list of Mio categories. We do have the tile for them, and we do have them listed. So when I mentioned that using Swift UI, we're declaring the UI, this is what I mean. So instead of saying draw something, do the animation, or put it side by side, our code is actually the structure. So we're saying we have a navigation view. Inside the navigation view, we have a list. Inside the list, we have an horizontal stack for each cell in our list, for each row of our list. We have an horizontal stack, which is composed by our image and then the name of the category, which is very neat and very viewable. We also do have like the on appear thing here. So every time our list appears, it will run the model fetch function that will call that will go there and contact the server, grab the categories, translate them from a JSON into a Neo categories object, and then we get that and we put that inside our categories variable here that is published. Being published, it will tell the Neo categories model that it had changed. Since it's an observable object, it will notify all the observers of it, which our content view is. So every time we change the categories inside our model, it will redraw our list. It looks like there's a lot of magic going under the hood. Apple does lots of this work for us. If we weren't using Swift UI, this would look a lot bigger. But yeah, we are leveraging lots of nice features from both Swift UI, from Combine, and we're leveraging Kingfisher. That is a dependency. It's a library of code from outside our app to show the image itself. So we don't have to write this code ourselves. Well, I spoke and live coded for like an hour and a half now, but we do have a pretty cool list here. And I want to start showing you guys at least how we can navigate from this list of categories to another screen before I can open for you guys to, if you have any questions that I can answer right now. But we will not be able to finish the thing here. Anyhow, I'll post the link to the full code from my repository on the chat before we finish, so you guys can take a look on how we can make a bigger app out of this. Sorry for like I mentioned, live coding is not always as smooth as we would like to. So we want to navigate. So if we touch on the screen on, let's say, beef, we want to show like all the beef dishes, right? So we do have a navigation view, and we want to create what we call a navigation link. So if we create a navigation link and say that our entire stack, horizontal stack, is inside a navigation link, when we click on our horizontal stack, we are going to be navigating to another place. The thing is, we lack the first one here. So let's do this again. Now the right way. So navigation link has this nice constructor here. We do have, oh, this is not the one we want. We want the label destination one. Destination label, there we go. So destination will be where we want to navigate to. So we have a closure for that. And we have a label, which is what we want to show, right? As a navigation link. So we take our horizontal stack, and we're going to say that our horizontal stack with the image and the text will be the label for our navigation link. And we're going to be navigating to a new screen. But what this actually is it expects some view, because that's what views do on Swift UI. So let's say we are going to be showing a text with the name of our meal category. So this is pretty bare, but okay, well, we do have to close that. Oops, close that parenthesis there, and we can run. It took a little while to show our list, but it downloaded and then it showed in. Now you guys will see that we have the caret symbol here. That means that Swift UI has created a navigation context for us. And if we click any of these rows, we'll navigate to another view. So if we click in beef, it will show our new text here, beef. And it will give us like the opportunity to navigate back to our meal categories list. And if we click in dessert, it will show dessert, and we'll be able to navigate back to our meal categories. And this is how we will navigate to new screens. So if we want to create a meal list view, we'll just create like a struct meal list view. We're going to say that it is a view, a Swift UI view. Being a Swift UI view, the compiler will want us to implement this body variable here that we also have on a content view here. So what we actually do is implement the body variable. That is some view. And we can do, for instance, take this text out of here, put it here. And then we can say, if we click on this navigation link, we will navigate to, well, in this case, we don't have like the meal category in this scope here. So let's say we'll have a name, which is a string, and we'll show the name. And we will, when we click on the navigation link, we will navigate to our meal list view. In our meal list view, we require us the name. So we'll pass the meal category dot name there. And well, it won't change, but this is how composable Swift UI can be. So we don't have to write the whole thing on the inline on the same file. This struct here could be in a different file. We could be doing like something like this, creating a new file, which is called meal list view. And it will be inside, well, it will be in the root here. And here we just create a structure. We'll import Swift UI. We don't need foundation. So it's on a new file. It's not here anymore, but it knows what we need. Takes a while to download the list. Downloaded the list, showed us the names and the thumbnails. And we go, there we go. We have the same thing now compartmentalized on its own file and its own class. We don't have to write the whole thing here. We just say this is a new list. If we wanted to, we could create, for instance, a struct. Meal category list row, which is a view. It will receive a meal category as a parameter. So it will be a meal category. It will have a body of some kind, and we can just, for instance, take this horizontal stack here, put inside the body here, and we can just say, okay, give me a meal category list row, and we're going to give the meal category that we have here as the meal category, and we compartmentalize that a little bit more. So it looks pretty neat. It's all compartmentalized, it's all modular, it's all, like I said, every view has its own responsibilities. We don't have to deal with anything specific from a row here. The row will know how to show itself. If we want to add something to the row, we add it here, and we don't have to change anything on the content view itself. So this is the nice part about having declarative UI. So yeah, sorry guys for taking too long to and not being able to finish the thing. But we are approaching the 10-minute mark. I want to open a little bit for questions if you guys have any, and we can close up. Like I said, the whole code for the app that is on, like that the demo that I put the demo on the slide deck will be available. So if you guys want to take a look at that, you'll have the source code for that, and you can run on your computers and that sort of thing. So yeah, let's get back to the slide deck. So you guys have the opportunity to scan the QR code again. I'll give you guys a couple of seconds for that. And I'll open for questions. So if you guys want to, oh, we do have a bunch of things on the chat. Okay. Is there a hackback for this? Samantha. Do you want to? Oh, okay, we do have. Okay, awesome. I'll open the chat for any questions now if you guys want to ask anything. Yeah. Oh, thank you guys for coming in and watching. Sorry for not being able to complete the thing that I wanted to show you. I think I have covered most of what I wanted to say and show. I think SwiftUI is a pretty good tool for you guys to be hacking with during the hackathon. So, well, if you guys want to be using it and have any questions, you guys are also very welcome to contact me on Discord or any of the previously shared social contacts I left there. Okay. Thank you. Do you have additional resources for further learning? Yes. So on the hack pack, I added a couple of nice resources. I'm a little bit, well, I don't like video tutorials too much, which is weird because I'm here video tutoring you guys. But I did add a lot of nice, well, at least 3 nice resources for further learning. Apple does have a pretty nice content about Swift, both Swift and Swift UI. They have like tutorials. They have like a book on Swift. So if you guys want to learn more about Swift itself, they have also very good resources. It's all on the hack pack. I can get back to you guys on Discord with that. But yeah, I do have some of those to add. So I'll work on that. No worries. I learned a lot from this workshop. Thank you, Julia, for being here. Thank you so much. Thank you so much. Okay. What time is now? We do have a little bit over 5 minutes, so I'll do my own merchandising here. So Shopify is hiring for 2021 new technical roles in 2021. So if any of you guys are looking into like internships or looking for any roles, technical roles, Shopify is hiring. So that other QR code will bring you guys to Shopify's career page. So if you guys want to check out, I do recommend Shopify a lot as a employee. I haven't been working there for too long, but I'll tell you, it's the best place I've ever worked at. So yeah, if you guys don't have any other questions, I guess we can finish early, or I can also go back to the code and try adding the second screen there, so you guys can see another maybe another server call plus another list of meals for specific categories. But yeah.
Thank you so much for your time, and thank you for presenting. This was very informative. And thank you for our attendees. Thank you for attending this workshop. And just a reminder that we have opening ceremonies at 7 p.m.
Oh yeah, I won't miss that. So yeah, thank you guys for attending. That was great for me to have like people listening. So yeah, thank you guys, and you guys have a great hackathon. I hope you guys well, at least learn and have a lot of fun, which hackathons are awesome for. So, well, this shirt here, I got from our latest hackathon that we had at Shopify. So this is the Shopify engineering hackathon. And I did have a lot of fun. I helped them with, well, it's a great opportunity that we have to work on projects that are not the ones that we are specifically allocated to. So it's a great opportunity to have some fun, learn some new stuff, get to know some different people, get to work on different contexts. So yeah, hackathons are lots of fun, and I hope you guys have fun with the SuperPOSITRON. Yeah, so yeah, thank you guys very much, and I hope I'll be seeing you again.